In section 15.5, we go over triple integrals for functions of three variables. So the basic idea is similar for double integrals, except now the region of integration is going to be a solid region within three-dimensional space. First, we're going to sort of go over the basic case where the region is a solid rectangular box, such as one that's displayed here. And so for a solid box like this, you have x varying within some interval, y varying within some interval, and z varying within some interval. So you can describe the box Q, x going between A and B, y going between C and D, and z going between R and S. And then you can set up the triple integral as an iterated integral like this. Here, depending on the ordering of the integration, you have to make sure that the limits of integration match up, right? So in this case, the innermost integral is with respect to x, so it goes between A and B. The next integral is with respect to y, so that goes between C and D. And then finally, the outermost integral is with respect to z, so that goes between R and S. Okay, so we've set up the triple integral in this way, but similar to double integrals, you can integrate with respect to different orders, but again, there's actually 6 different orders that you can do, and you can imagine how to rearrange these integrals to make sure that the ordering should match up. Okay, so how do you calculate the triple iterated integral? So just as for double integrals, you start from the inside, right? So in the innermost integral, it's with respect to x. So you think of y and z as both as constants, and you integrate with respect to x. Once that's complete, the next integral is with respect to y. So you'll hold z constant and just integrate with respect to y. And then finally, in the last integral, it'll be a regular single integral with respect to z. So that's the basic idea. And then finally, geometrically, this integral would be for some kind of four-dimensional volume, right? So so we don't actually visualize it, right? Because the function would sit in four-dimensional space over the solid region Q, but we can't really visualize four-dimensional space. So typically in a problem, we'll just try to visualize Q within 3 dimensions, and then just set up the integral accordingly. Okay, so that's the basic setup for a triple integral over a rectangular box.